We're still talking about absolute value equations here. So just like last time, we are solving absolute values that have variables. Our ultimate goal is to solve for the variable. Um, but when we look at our problems today, they're going to be a little bit more complex. So we're adding a few more steps to what we did the time before. So we're going to have some steps and multi-steps in here. And again, we will always end up with two answers when we're done. Okay. So then let's start by looking at number 6. This is going to be a two-step equation, but remember it's an absolute value. First thing we do with absolute values is isolate our absolute value. You got to make sure there's nothing on the same side as the absolute value that's outside of it on one side of the equal sign. So this is actually already isolated. So then we move on to the next step, which is to split it into two different equations. So when I split it into two different equations, I'm just going to change what it's equal to a positive version, which it already is, and a negative version of that number on the other side of the equal sign. So I'd have negative 4 plus 5x equal to 16, and I'd have negative 4 plus 5x equal to a negative 16. Okay, then these are party problems, right? Got my acquaintance, best friend. Acquaintance is going to leave first, right? We're going to add 4, get our acquaintance out the door, and cancels out. And then I'm left with 5x equal to 20 on this side. And I'll just solve this first. So divide by 5, divide by 5. X is going to equal 4 on this side. There's one of your answers. Let's look over here on this other equation. So again, we're going to get rid of our equation first. So we're going to add the 4 out the door. And it is gone. And I'm left with 5x is equal to negative 12. Hooray, hooray, this is going to be a decimal. That will happen sometimes with these absolute values. They don't always work out nicely. So then we divide by 5. You could leave that as negative 12 over 5, or 12 divided by 5 is going to be a decimal, which is 2.4. It'll be negative 2.4. Okay, and that would be the answer there. But let's look at one of these more complex ones. So if we turn over and look at the other page, let's look at this number 15 here. So number 15, we have this party problem on top that's an absolute value. But down below, this 8 is not actually going to be part of this absolute value. So again, we need to isolate our absolute value first in order to split it into two different equations. So we need to get rid of this 8 first. If we think back to our party analogies, if it's under everything, that's our creeper. To get rid of our creepers, we have to multiply, right? Because right now it's dividing. We have to multiply to get rid of them. So we multiply this side by 8, get them to cancel out, but multiply this side by 8. We must multiply this side by 8 to make sure it remains equal. Okay, so after we do that, we're going to get the absolute value of 7p plus 4 is equal to 24. Now my absolute value is all by itself. I can get rid of the absolute value and split this into two different equations equal to a positive 24 and a negative 24. So I'd have 7p plus 4 is equal to 24, and 7p plus 4 equal to negative 24. And then I'd solve it just like any other party problem. I get rid of the acquaintance, so I minus the 4 out the door. Gives me 7p is equal to 20, which divide by 7. It's going to give me a decimal. P is going to equal 2.857. I'll just round it up to 0.9. Okay, then I'll do the same thing over here. So I minus the 4 out the door. That gives me 7p is equal to negative 28. Divide by 7. P is going to equal negative 4. So those are my two answers for that problem right there.